Inverse functions. I'm going to give you a function. I'm going to ask for its inverse. This is something, relatively speaking, very easy to do. Okay? The very basic premise of finding an inverse function is that you switch x and y. In some situations, you're done after you switch x and y. In some situations, there's one more step. If I give you an equation like this, y equals 2x plus 5, and I ask you to switch x and y, in order to get back to the regular function, what do you have to do then? You got to get the y by itself again, right? You got to solve for y. So our steps that we're mostly going to talk about to find an inverse function are we're going to switch x and y, and then solve for y. Knowing that sometimes once you switch x and y, you're done. Let me give you one of those situations right off the bat. Okay? If I say to you, students, here's your function. Your function is 1, 5, 2, 6, 3, 7, and negative 2, negative 4. That's your function. How are you going to find the inverse? How are you going to find it? Switch x and y. So the inverse would be what? 5, 1, 6, 2, 7, 3, negative 4, negative 2. Guess what? We're done. This is a situation where once you switch x and y, you're done. I found the inverse. Okay? Sometimes in these situations, well, first of all, I need to check and make sure you remember your vocabulary for this particular section. How do I know that this first thing that I gave you, I called a function? How do I know for sure it's a function? Do you remember? When I give you a list of points, how do you know if it's a function or not?
No x is repeat.
Hey, because no x is repeat. Is this a function?
Yes.
A 1, a 2, a 3, and a negative 2. Are any of those repeating x's? No, so it is a function. Now, I told you that from the beginning. I want to make sure you remembered the definition of a function. Okay? Because sometimes when you're given a function, it says, find the inverse. Okay, we did that. The second part of the question is the inverse a function? Well, if you don't remember the definition of function, we're in trouble, aren't we? Okay? So tell me now then, is this inverse a function? Yes, it's a function. Why? No x's repeat. Now, somebody said a minute ago we could graph it. I agree with that. I even gave you some graph paper. Not for that reason, but we could have used it for that, right? How would you have known by looking at the graph if it was a function or not? Oh, the vertical line test? Yeah, that's exactly how you would know. The vertical line test, right? If we ran our pencil over the piece of paper, does it touch more than one dot at a time? If it doesn't touch more than one dot at a time, it is a function. If it does touch more than one dot at a time, it's not a function. Okay? So, on a scale from 1 to 10, 10 being really hard, 1 being really easy, where is this? 1. I'm seeing lots of 1s and maybe some 2s, but pretty easy, right? Okay. Does it get harder? Maybe to like a 3. Okay. Now, I gave you this example earlier as a problem. Let's actually go do that one. Okay? Let's go to our graph paper so we have it right nearby. I said, well, first of all, y equals 2x plus 5. 2x plus 5. Is y equals 2x plus 5 is a function? Is that a function? Yes, it's a line, right? You know that from previous experience. Okay? How do I find the... Well, should we graph it first? Yeah, let's graph it first. How do I graph this line? Up 5. 1, 2, 3, 4, 5. And then? Up 2, right 1. Up 2, right 1. Up 2, right 1. Remember, 2 over 1 is our rise over our run. Remember that? Could I also go down 2? If I run backwards 1, right? Down 2, left 1. Now, I know you think I'm being silly, but I want you to go all the way to the edge of the graph, and you'll see why in just a minute. Did I miss one? No. Okay. And this is our function, y equals 2x plus 5. I'm going to draw the line, or are you okay with me just leaving the points there? Good? Okay. I want to find the inverse of this function. How do I find the inverse? Absolutely. I need to switch my x and my y. Just the x and the y, not anything else. X equals 2y plus 5. See how I didn't move the 2? The 2 stayed exactly where it was. It was only the x and the y that I switched. Okay? Now, is that in a form that we're used to? No. What's wrong with it? Y is not isolated, right? Y is not by itself. If we're talking about the equation of a line or an equation of a whatever it might be, I really need it y equals, don't I? So this is one of those situations that after I switch x and y, I have to solve for y. Okay? How do I solve for y? How do I isolate the y? Subtract 5 from both sides. I heard you. X minus 5 equals 2y. And then divide by 2. Good. How do I write my answer? Here's a better question. Is there only one way to write my answer? I can think of 3 just off the top of my head. 6 if you want to be argumentative. I could write x minus 5 over 2 equals y. I could write 1/2 x minus 5 halves equals y, right? If I divided each of them by 2. I could say 0.5x minus 2.5 equals y. And then, if you're like a purist, you could also say y equals x minus 5 over 2, y equals 1/2 x minus 5 halves, or y equals 0.5 x minus 2.5. As long as you realize these two are the same, these two are the same, these two are the same. But the bottom row is written specifically in y equals, right? Instead of the other way around. Are you okay with either way? Good, I need you to be. Okay? So which one of these 6 equations am I going to choose to graph? We already agreed that they're all the same, right? They're just written in different ways. Which one would you choose to graph? The first one is probably the one I would not choose, because I can't see a y-intercept easily and I can't see a slope easily. The third one, probably, okay? One of these two. I'm very glad that you guys aren't thrown off by this one, because some people have to write it in this form, and I need you to be a little bit more flexible than that, okay? If you are one of those people that have to write in this form, I'm not going to shun you, okay? Not to your face. Just teasing, okay? So how do I graph this equation? What's my y-intercept? Down 2.5. And what's my slope? My slope is 0.5. which I could represent in two ways. It could be 0.5 over 1, which is kind of weird, which is it's also what? 1/2? Aren't those the same thing? Yeah. Now, the weird part is, this means go up half and over 1, right? That's kind of really helpful here because I'm already at a half. If I go up a half and over 1, that puts me right there, doesn't it? Right on a dot. And then I can go up 1 over 2 because it's the same thing, isn't it? I could go down a half and over 1. That gets me on a nice clean dot. And then go down 1, left 2. And this is my y equals 0.5 x minus 2.5. Now, there's one really, really important thing that we've got to talk about, but we can't do it yet. So we're going to pause on this particular problem and do another one. Okay? Everybody have this one? Okay, so far? Okay. Let's do another problem. I'm going to tell you that my original function is y equals x minus 3. Y equals x minus 3 is my original function. How do you find the inverse? Oh, well, let's graph this one first. Let's graph this one first. If you've already started finding the inverse, don't erase it. We'll go back. How do I graph this? Down 3. And then up 1, right 1. 1, right 1. And again, I know you think I'm being ridiculous by putting every single dot on the paper. I don't care. Do it anyways. Now, how do I find the inverse? Switch them. Switch x and y. When I switch x and y, I get x equals y minus 3. So how do I solve for y? Perfect. Add 3. X plus 3 equals y. How do I graph that? Up 3. Up 1, right 1. Y equals x plus 3. Okay so far? Okay. We're going to do one more before I reveal our secret. Y equals negative x plus 2. How do I graph that? Good. Up 2. Down 1, right 1 this time, right? Or up 1, left 1. How do I find the inverse? Switch them. Switch x and y. I get x equals negative y plus 2. So how do I solve for y? Good. Subtract 2 from both sides. X minus 2 equals negative y. And then multiply both sides by negative 1. So I get negative x plus 2 equals Why? Do we do something wrong? Why are you guys looking at me like it's weird? It's exactly the same thing, isn't it? The inverse of the function is the function itself. Is that allowed? We just proved that it was, right? We just proved it, okay? So, I don't want to graph it again because my dots are going to be exactly on the same places they were before.
Can I look at yours?
Absolutely. Okay? So here's the deal. There is a line that I can put on every single one of these graphs in exactly the same place on every single one of these graphs that is a line of symmetry. Could you see where that line might go? I'm seeing some nods. I'm seeing some people who are forgetting that it's okay to talk and guess, even if they're wrong. Where do you think it might be? Now, let me tell you about last period. Last period got a little confused. Not confused, that's not the right word. I don't know what word it is, so I'm not going to try one.
Are you getting warm?
I'm warmer because the kids are in here. Their body heat,
Right.
you know.
All right.
But
I'll keep it on.
thank you so much.
Yeah, sorry, Bobby.
It's all good. Anytime we've talked about a line of symmetry before, what's been true of that line of symmetry? It's been this way, right? Up and down. Is that the only way a line of symmetry can go? How else can it go? Yeah, it can go this way, can't it? Is that the only way it can go? How else can it go? It can go any way I want it. What has to be true about the line of symmetry? It has to be straight because it's a line. That's a very good thing to know. But it has to be somewhere on the paper so that if I folded the graph along that line, what's true? Same on both sides, right? So do you see anywhere that I could put the line? Like this is probably the easiest one to see. Where's the line of symmetry? Right here, right? So you're telling me it goes to the origin and it's kind of like diagonal? What if I put that line exactly the same place on this graph? Is that the line of symmetry? Okay. What if I put it here? Is that still the line of symmetry? Yeah, it is, isn't it? Because if I folded these together, wouldn't they be right on top of each other? If I folded these right on this line of symmetry, won't these two lines be right on top of each other? Even here? Yes. Okay? This line would be right on top of this line. This line would be right on top of this line. Guys, what's the equation of that line? Here was the easiest place to see it, right? So it went right in the middle, right in between these two. What's its y-intercept? 0, because it goes to the origin, right? What's its slope? 1. So what's the equation of the line? What? Y equals x? Is that important? Yeah, the answer is yes. Okay. Y equals x. What did we just do here to find the inverse? We made y equal x. And we made x equal y. That's why it reflects over the line y equals x. Every single one of these graphs that I draw, I'm going to have this imaginary invisible line, y equals x, on it to help me remember, first of all, how to find the inverse. I make y equals x and I make x equal y. But it's also another way for me to check to make sure that I'm doing it right. If the lines intersect, where should they intersect? Right on the line, right? If they don't intersect, which means they're parallel, then they should have the same slope. Do these two have the same slope? Yeah, so they won't intersect, but they'll be parallel and equidistant away from the line y equals x. What the heck is happening with this one? These two lines are perpendicular, aren't they? Now I know that because the equation of this line is y equals x, and the equation of this line is y equals negative x plus 2. The slopes are opposite reciprocals of each other, aren't they? So I know that they're perpendicular. Anytime I graph something, I want to graph the line y equals x. It's never going to say graph the function its inverse and y equals x. It's only going to ever say graph the function and its inverse. But you always want this line here when you're graphing inverse functions, so you can say, okay, wait, if I fold this right here, is that going to be right on top of each other? And sure enough, it is, right? If I fold this right here, are they going to be on top of each other? Yes. If I fold this right here, are they going to be on top of each other? Yes. Kind of like a little help, a little guide for you to know about. Okay? Lauren, can you reach behind you on that desk? There's some worksheets. Your homework tonight is going to be on these worksheets, and I'll tell you which problems to circle so you know which ones to do. Okay? There's 28 problems on the worksheet. I'm not making you do 28. I think you can understand the concept before 28 problems. Okay? Let me show you, however, why I waited until now to do this. Because above all, I don't want you to think that I think you're stupid, because that's like the farthest from the truth. Okay? What if we had a problem like this? Y equals the square root of x plus 2. How do you find the inverse of this function? Well, first we have to switch x and y. Okay? So when I switch x and y, I get x equals the square root of y plus 2. Right? How do I solve for y? Yeah, if we'd never done square root problems before, would you have known what to do?
No.
Probably not, right? So if I square both sides, what do I end up with on the left-hand side? X squared. What do I end up on the right-hand side? Y plus 2. How do I solve for y? Perfect. Subtract 2. X squared minus 2 equals y. Done. Boom. What about if I said the function was y equals x cubed minus 4? How do you solve this one for the inverse? Switch x and y. X equals y cubed minus 4. And now solve for y. What do I do first? Close. Add 4. I know. X plus 4 equals y cubed. How do I get y by itself? What? Cube root both sides, right? Like that? Y equals the cube root of x plus 4. Done. Now, if I was going to ask you to graph something like this, I would give you a calculator. Or we could use a table, right? I would give you a table. Questions? Okay, on your worksheet, please circle these problems. Number 1, number 2, 3, 7, 11, 13, 15, 18, and the 4 on the back. 25, 26, 27, 28. Okay? Any questions? I know you know this, but just reminding you, since it's a new semester, the problems that I did not call out as ones that are required for you to do, we just ignore them? If you want, right? If you want, can you just ignore them? Absolutely. But if you do them, extra credit. Any questions? All right, get set, go. Peace.